The James Webb Space Telescope is turning out to be one of humanity's most significant triumphs in space observation. The scientific world has great hopes for the Space Telescope because it is significantly more powerful than any other space observatory ever deployed by humanity. It will allow them to investigate very distant things in space, which they have never been able to before. Proxima B will be one of those objects studied by the JWST in order to determine whether artificial light is emanating from the planet. Scientists want to know if the lights from Proxima B are the result of aliens. Hello there everyone, welcome back to our channel. In today's video, we'll talk about the alien civilization discovered on Proxima B. To receive notifications whenever a new video is uploaded, you must first subscribe to our channel and click the bell icon. What will the JWST see when it zeroes in on the exoplanet, and how will this influence you? Join us as we investigate James Webb's artificial light finding on Proxima B, which has the potential to transform everything. Let's get started right away. Exoplanets dot the sky and hold many secrets. These are planets discovered outside of our solar system. Most of them orbit other stars, but rogue planets or free-floating exoplanets orbit the galactic center and are unattached to any star. While exoplanets are abundant, the majority of those discovered so far have been found in a very small part of our galaxy, the Milky Way. In fact, the galaxy contains more planets than stars. Scientists may see compositions ranging from relatively rocky, like Earth and Venus, to very gas-rich, like Jupiter and Saturn, by measuring exoplanet sizes using diameters and masses using weights. Exoplanets are composed of elements similar to those found in our solar system, but their compositions may differ. As a result, some planets may be dominated by water or ice, whereas others may be dominated by iron or carbon. Astronomers have discovered molten sea-covered lava worlds, fluffy planets with a density of styrofoam, and dense cores of planets still orbiting their stars. The first exoplanets were discovered in the 1990s, and hundreds more have been discovered since then using various detection methods. However, astronomers rarely see an exoplanet through their telescopes in the same manner that you see Saturn through a telescope from Earth. This is known as direct imaging, and only a few exoplanets have been discovered this way, with the majority of them being young gas giant planets circling quite far from their sun. Because these exoplanets are difficult to identify using existing telescopes, scientists must rely on indirect ways to find them. One indirect method is to measure the dimming of a star when a planet passes in front of it. This is referred to as the transit method. Monitoring the spectrum of a star for telltale signs of a planet pulling on its star and causing its light to gradually Doppler shift is another way used to detect exoplanets. Thousands of planets have been discovered using space telescopes by watching transits, which are the little dimmings of light from a star as its tiny planet passes between it and our telescopes. Gravitational lensing, often known as the wobble method, is another means of detection. Detecting exoplanets is difficult, but analyzing them once they've been discovered is even more difficult. As a result, scientists have not been able to investigate one of the most popular exoplanets, Proxima B, as thoroughly as they would want, despite all of the exciting discoveries they assume it conceals. Is the exoplanet, for example, home to alien life? They now have a new tool at their disposal. However, the James Webb Space Telescope. The JWST is not the first human-made telescope in space. NASA has a long history of studying the universe with sophisticated observatories flown into orbit. One of the most famous and powerful is the Hubble Space Telescope, which has faithfully supplied spectacular photos of various parts of the universe for several decades. The JWST, on the other hand, is many orders of magnitude more powerful than the Hubble and therefore significantly more expensive. The JWST is the most expensive telescope ever launched, costing about $10 billion. It's also the most difficult, with various pieces meant to be folded up. They had to be folded up so that the telescope could fit on the rocket that would launch it into orbit. The JWST is located a long distance away from the Hubble Space Telescope. The former orbits the Earth at a distance of around 350 miles, whereas the latter rotates around the Sun at a distance of roughly 1 million miles. This means that NASA will be unable to send astronauts to fix or reconfigure the JWST after launch. The JWST's large primary mirror, which measures 6.5 meters across, allows it to capture things billions of light years away, thereby transporting us back in time. In fact, the JWST will allow us to snap newborn images of the universe since we will be able to approach as close to the Big Bang as feasible. The new telescope detects signals from heat-emitting objects thousands of kilometers away using infrared technology. NASA installed a shield beneath the telescope to insulate the space observatory from interference from the Sun and Earth's heat. The shield, which has 5 layers, is so large that it'll cover an entire tennis court. NASA has released a mosaic of the JWST's initial photographs illustrating the early phases of the telescope's 18 main mirror segments properly aligning before it reaches its full capacity. While the image is somewhat grainy, it is a decent beginning point in the lengthy process of modifying JWST's mirrors in order to obtain ultra-sharp photos of the distant universe. The image's 18 spots of light all depict the same star known as HD 84406 as seen through a different main mirror section. It took roughly 25 hours to collect the light necessary to create the image mosaic. The 18 photos of HD 84406 were assembled from almost 1,500 photographs acquired when Webb was oriented to various positions around the star's estimated location. Following the various adjustments that the telescope will make over the coming months, the mirror will begin to align appropriately and the 18 stars will eventually become one as all of the mirror segments are aligned to produce a smooth surface. Why are astronomers so intrigued by the Proxima B exoplanet? Our nearest nearby star is Proxima Centauri, which is around 4 light-years away. Proxima Centauri, like our Sun, has its own group of planets around it. One of the planets in the Proxima B star system. This exoplanet was discovered in 2016 and has piqued the interest of astronomers ever since. Scientists have also detected Proxima C and Proxima D, though Proxima D has yet to be confirmed. However, for a good cause, Proxima B has received a lot of attention. Because the planet orbits smack in the middle of its star's habitable zone, liquid water and possibly even life could exist there. Because of its Earth-like mass, scientists believe that Proxima B could not only have liquid water, but could also be a rocky terrestrial planet like Earth. Proxima B revolves around a star that, while close to our solar system, is much brighter and less massive than our Sun. The exoplanet is tidally locked and rotates in sync with its star, so one side is always facing the star and the other is always facing away, a light side and a dark side. Furthermore, it is unknown whether Proxima B has an atmosphere. However, if Proxima B has an atmosphere, the simple elements needed for the production of biochemical cycles that we term life, water, carbon dioxide, and rock, might all be present and interacting on the planet's surface. The planet revolves around its star every 11 Earth days, completing one orbit. The temperature on the planet's surface might range between -90 and 30 degrees Celsius, that's -130 and 86 degrees Fahrenheit. What if Proxima B is inhabited by aliens? If this is the case, it is thought unlikely that life could emerge on the day side due to the host star's constant stream of powerful radiation. The explanation for this is that Proxima B orbits the Sun at only 4.5 million miles away, or around 1/10 the distance Mercury is from the Sun at its closest point. Radio transmissions have already been discovered in the vicinity of Proxima B. However, radio astronomers believe this was most likely due to natural interference. As a result, because the side of the exoplanet free from radiation is always dark, any civilization occupying the exoplanet may need to deploy powerful mirrors or very brilliant LED lights to illuminate its cities. This can assist us in detecting them with the proper tool. This is why a team led by Harvard astronomer A.V. Loeb has proposed that the JWST be used to detect traces of LED light on the planet Proxima B. They believe that by utilizing the near-infrared instrument on the James Webb Telescope and look for telltale signals of LED light waves in the light from the planet and its host star, they will be able to detect the presence of artificial light. By computing light curves from the planet and its host star, the scientists tested if artificial light could be seen on the dark side of Proxima B. These researchers evaluated 2 scenarios: artificial illumination with the same spectrum as frequently used LEDs on Earth, and artificial illumination with a narrower spectrum that results in the same proportion of light as total artificial illumination on Earth. Let us know what you think about the JWST discovering Proxima B exoplanet aliens in the comments area below. That was the end of it. Thank you so much for taking the time to watch this. If you liked it, please tell your friends and subscribe to our channel for more great videos and up-to-date information. We look forward to seeing you in more future videos.